Over the next couple of videos, we're going to take a look at the miscellaneous kind of lipids. So there's the essential and there's non-essential fatty acids. So non-essential fatty acids would be the ones that we can synthesize ourselves. Then we're going to look at some eicosanoid biosynthesis and cholesterol biosynthesis. And so we have a picture of some intermediate stages of cholesterol biosynthesis right here. Now in fatty acid synthesis from acetyl-CoA, so I'm going to come in here and put acetyl-CoA. The first major fat produced from acetyl-CoA in our bodies is palmitate or palmitic acid. Somewhere between 21 and 30% of our fat stores in our body are from palmitate or palmitic acid. And from there we have enzymes that can elongate it or desaturate it, producing other fatty acid products. So all of these would be examples of non-essential fatty acids. Now some plants have enzymes that can produce linoleate and alpha-linolenate. However, humans do not. And so all of these and their byproducts, and some of their byproducts, these are considered essential. So it's essential that we eat these or we don't get them. Now why is it essential? Is because they create things that our bodies need. So for example, there's anti-inflammatory signaling that we get from omega-3s from plants and fish, and then pro-inflammatory response that we can get from the downstream products of linoleate. Now eicosanoids are considered local hormones. I'm going to write that, local hormones. And they're going to act either on their own, the cells that produce them, or on nearby cells. So typically we're going to say nearby cells. And the reason we're saying nearby cells is because these things are rapidly degraded, and so they're not transported throughout the whole body. They break down too fast. And one thing I like about this slide, just as a side note, is we have a really cool $5 word. I already said it wrong. Hydroperoxyeicosapentaenoic acid. And they also have the hydroxyeicosapentaenoic acid. And to be quite honest with you, I don't know why either of these, what they are doing in the context of the rest of this slide. But kind of the general idea of this is that membrane phospholipids are used to produce eicosanoid lipids. And then eicosanoid lipids are active in platelet aggregation, vasoconstriction, vasodilation, inflammation, and these leukotrienes, inflammation, bronchoconstriction, mucus secretion, and anaphylactic shock. And of course, the pathway that most of these things are going through is through these hydroxyeicosapentaenoic acids, or the hydroperoxyeicosapentaenoic acid. But why we need to know what they are, I don't really know. Now, of clinical importance is the COX-2 and COX-1. So cyclooxygenases, the non-steroidal anti-inflammatory drugs such as aspirin. Aspirin is a permanent inhibitor of the COX-2, and so it stops some of the inflammation pathway. And other non-steroidal anti-inflammatory drugs have similar mechanisms of action either on COX-1 or COX-2.